Today we are going to look at the BlackNet RAT. Now the BlackNet RAT is mentioned as a remote administration tool, however it is as much a remote administration tool as it is actually a remote access Trojan, for lack of the better term RAT. Now this particular tool was freely made available on GitHub back in 2020, and this was during the height of the COVID pandemic, where people were being infected by this particular rat during that time with COVID-19 lures. Now, what actually happened was those systems were then recruited in what's known as a botnet and were used not only to steal information from those systems, but also execute attacks on other remote systems. Now, because it was freely available on GitHub, we actually get a glimpse into what the developer has created here. So let's jump in. So we've actually got our BlackNet RAT here, which is downloaded from Malware Bazaar. I'm going to extract this, and it needs the password infected. From here, now I have an extracted copy. Now, something that might be noteful is that this appears to have an icon, if we zoom in, that looks like it might be a self-extracting archive. Now, I can actually use 7-zip and go open archive, and we can see that it actually is, because this functioned quite nicely. So inside of it, there is an Updater.exe. Now, if I was to open this up in PE Studio and view the particular archive, you can see the manifest says that it is a WinRAR self-extracting archive, and the overlay has a pkzip file, which is the actual archive inside of it. So you could actually save this to a file. Let's say we are going to save it as zip.zip on the desktop, and now that overlay has actually been saved to the desktop. Now the self-extracting archives have a decompression method that is the stub used to essentially extract that archive. So whilst we can use 7-zip to get it to open it directly from here and get the next stage, we can actually extract the archive like we just did and go open archive, and this is actually what we are seeing. We are seeing Updater.exe here after we have dumped it from that overlay. So let's go ahead and extract this file. So now you'll notice that Updater.exe seems to be another copy of a self-extracting archive. So using PE Studio, once again, we'll take a look at it. And as we can see once more, it does look like this is a WinRAR self-extracting archive. So we have once again another overlay that is an archive file. This time we are just going to simply hit it with 7-zip and use extract files. Now you'll see that it is posing as Adobe Photoshop CS12, and it has a file size of 195 kilobytes. If I look at this file with Detect.exe, we can get a bit more of an idea of what this actually is. Now it does look like it is a .NET binary, which means that it is very easy for us to decompile. So using DnSpy, what I'm going to do is open up this file and take a look at what it contains. So opening up this file, you'll notice that it, number one, doesn't match the name of what we were just seeing. This says that it is the host process for Windows services, so SVCHOST is what that would be, but then it also says the assembly title is the Windows Update Assistant, which doesn't align even with the fact of a host process for Windows services. We can see that it is masquerading as SVCHOST as the binary name here. And if we actually begin to look at it, it doesn't have a lot of methods, but you can already begin to see that some of the names just don't add up to what they should be. For example, DDOS is a distributed denial of service, and that's not something that we would expect the Windows SVCHOST process to be performing. So let's take a look at some of these methods. SVCHOST itself is likely going to be the entry point, or what is going to be run as the form is created. Now, there is quite a lot in here. This actually begins to look like the configuration of this particular malware. So there are particular settings such as an ID, whether it's going to persist on startup, whether it does a hard install, whatever that means. whether it's got a USB spreading module, whether it's trying to bypass UAC, anti-VM checks, etc., etc. So this looks like the main configuration of this piece of malware. Now, if we take a look at the SVCHOST antis, this is quite nicely named anti-VM. So this is performing checks to determine if it is running in a particular virtual machine. And there doesn't seem to be a lot of checks that are being performed, but if any of these particular DLLs are found, so this looks like a VirtualBox one, and this looks like a VMware-based one. If either of those DLLs are found, or even if a sandboxy DLL is found, then it's going to be running a command where it is attempting to delete itself from disk. So it's just going to vanish, thus trying to remain undetected. There is also an anti-debugging check. Now this actually has a hard-coded list of particular executables such as a PATI DNS, SpeedGear, Wireshark, a bunch of tools that are used in debugging and malware analysis that if it finds them on an operating system is probably once again going to kill itself. Hello, it's Jai here from the future. This is not actually going to kill itself. It's going to kill each and every one of the processes that are running with those particular hard-coded process names. So yeah, silly me, didn't actually read the code properly when I was making the video. Alright, back to the show. Now if we look, there is a disable WD, which is disable Windows Defender. And this is modifying a number of registry keys in order to prevent the anti-malware scanning engine of Windows Defender from performing scans against this binary. So for example, it is turning tamper protection off, it is enabling the disable anti-spyware component, so it's removing that scanning aspect of it, disabling behavioral monitoring, disabling on-access protection, and disabling the real-time scanning. So it's trying to use PowerShell in order to disable Windows Defender as well by using the set MP preference commandlet. And so what it's trying to do is just disable any type of monitoring using PowerShell. And we can see it also has this run PS method. Now if we go down further, we can begin to see SVCHOST DDoS, and we can look at what this is. So this says start arm, and perhaps this is arming an attack that it's about to perform. And you can see that it has post data, host to attack, and whether attack is running. And it looks like it is trying to attack particular websites or domains associated with whatever is sent to it to perform this attack. So that's quite interesting, and it looks like it's maybe doing that by sending a number of head requests to the particular server, trying to overload it. There is this lull method, which kind of just looks like maybe that was what they named a method that they had to use to do these things. Look, I digress. Now, if we go down further, there is bandwidth flood. So there looks like there are different DDoS methods that can be used here. There is get methods. There is post methods to servers. And there is even UDP-based floods, so sending UDP packets to a particular server, and slow loris, which I'm not 100% sure what slow loris is, but perhaps this is a way of performing the attack where it's going to be doing it slower to remain under the radar. Now, we can see a few supported methods here, or supporting methods. So HTTP socket, where it's likely encrypting traffic to and from the server, and HTTP here. And you'll notice something that's a bit interesting is that there is this BN delimiter for the BlackNet malware, and it's sending data delimited by this to a particular command and control interface. So it does look like it's also receiving particular commands back. If we go down further, there is the my application. I guess this is creating the actual form when it starts, which kicks off all the code. And there's probably not too much more within these classes that are of interest. However, you never know. Okay, so maybe it can take particular blacklists or particular host names and actually change what the configuration of this particular botnet has so that it points somewhere else. So that's a little bit interesting. Moving down, there is this other method. So it does look like it's got a browser handler. So maybe this is actually bringing up a particular web browser and opening a web page, which is what it looks like it might be doing. And then there is a binder service. Then there is also a lime logger. So that's a little bit interesting. This looks like it's likely a keylogger, and you can see the hook callback being defined, and it's looking if the left control key is pressed, and if it is, that gets translated to control. And this is kind of a key indicator that you can look at when you're looking at keyloggers, because the special keys aren't necessarily known. And so how you show that someone is pressing a special key when it's logging what's been typed on a keyboard is to, generally speaking, add these brackets and the special key that's being pressed. Otherwise, a keylogger, if you type the word dog, for example, but then you hit backspace and let's say you hit it twice and then you did ILL instead, you would have typed the word dill, but they would have seen that you typed the word dog-ill. So without having some sort of idea on what the backspace key was that was pushed, you're not going to know what was actually typed properly at the keyboard. So that's why some of these things exist. Moving along, we can see there is a remote desktop component to it. So it does look like it's going to take a screenshot of the desktop, tie it back to the ID of this infected bot, and then send that off to the particular command and control interface as well. And so there is also persistence. So it looks like it has different methods. This one quite simply is using a scheduled task and creating it on the environment so that this runs at startup. This one is using a registry run key for the particular user and using that as a method of starting at startup. And this stealth mode here seems like it is maybe doing something a little bit more, but the key components here seems to be that it is creating hidden files on the endpoint. So it's setting the attributes so that they're hidden unless you've got show hidden files enabled. And there is also spreads. So it does look like there is a module where it is copying to a particular Dropbox instance if it finds that on the host, and then also copying to USB. So this is quite interesting, and all of these seem to have the hard-coded name Adobe Photoshop CS.exe, so it's all trying to masquerade as Adobe Photoshop by default. I just want to go back and look at a few more things in this form. So first off, there is what looks to be a mutex being created. So this is likely, if you have that mutex on your system, that it won't run again to infect the host. So it's probably checking if that mutex is there, and then if it is, it's not going to run to infect the host again as a way to prevent any kind of duplicate infections on a system. So this is interesting because it does seem to have an identifier and this BN part of the string to say it is tied to the BlackNet malware. Now moving down, there is a few different components such as uninstall commands being received, updating the malware. There is actually in the clear this BlackNet.dat. So this is once again an indicator that this is the BlackNet malware. There is sending to say a host is online. There is all of those checks, so bypass scanning, anti-debugging, USB spreading. One interesting thing here is that if it is spreading to a USB, it does look like it might be changing the name to Windows Update.exe or Windows Update.exe as opposed to what we saw with the Adobe Photoshop. There's also mention of, under the stealth mode, it looks like it's using environmental paths and then adding it under a Microsoft My Client in order to maybe remain hidden wherever it's establishing persistence there. And you can see down here, it's got mention of getting the command, comparing to see if it's a standard ping or whether it gets the conditions to say start a DDoS attack. And you can see that it is sending stuff back like success, UDP attack started. And this actually goes on for quite a lot. And then there's other commands. So this basically gives us an idea of what the malware is going to be able to do. So uploading files and executing them, opening a web page, uninstalling it, executing a script that has been given to the malware, closing off the connection to this particular command and control server, moving it onto a new system. So that's a little bit interesting. Blacklisting a particular client, taking a screenshot and uploading that to the remote server, the command and control, getting a list of running, actually this looks to be getting a list of installed software on the system, maybe stealing cookies on a particular system in order to get access to web browser sessions. There is also taking the particular cryptocurrency wallets from this particular system, starting a keylogger, maybe retrieving the logs, stealing passwords from the system. So this is interesting because it's going for the cookies once again, logging off a system, so kicking someone off. This looks to be where it's actually getting the Chrome, so Google Chrome cookies on a particular system. Then there seems to be one for Firefox. And under PowerShell, it's running it with a window style of hidden and an execution policy of bypass to ensure that it remains undetected on an endpoint and is allowed to run. So it does look like it's checking to see if it is running from a USB as well, but this seems to only be checking the executable name. So on a USB, maybe it's called Windows_update, whereas on an endpoint, it was pretending to be Adobe Photoshop. And it does look like it's getting information from your publicly facing IP address, perhaps, in order to determine where you are in the world. There is this self-destroy, which is basically trying to delete the executable after it kills it. There is the update. There is the uninstall. So this is proper nuking of things. Getting the MD5 hash, opening a hidden web browser. So maybe this would be used in order to attack a web page, or maybe you just want all the botnets to be opening up an invisible browser to get click fraud type of ads or some sort of ads revenue from particular systems in this botnet. Checking if you are an administrator on a particular system as well. Stealing passwords. So this now is using a particular DLL that's going to be dropped onto the system based on whatever plugin is pushed down. Getting an idea of what antivirus products are running. So this is going to use the Windows management instrumentation in order to select star from your antivirus products installed. Restarting it as an administrator is a command. Getting the programs that are run. And this seems to be some sort of random array that's being used to build maybe a string that can be used elsewhere. There's also getting hardware information. So that's interesting to see what drives you have on a particular system. There is comparing directories. And yeah, that seems to be the crux of this particular malware that can recruit you in as part of the BlackNet botnet. Hi everyone, just letting you know it is a new day, so I do have a new hairstyle and I'm wearing a new shirt. Now today I'm going to show you the BlackNet RAT Builder. So I do have a copy of the BlackNet Builder here, and this has a radioactive icon associated with it. It does have the company name Dark Software Co. and black.hacker, which is the alias used by the person who created this particular tool. Now, there is a stub, which is a PHP stub that's associated with this particular BlackNet RAT and is required to use the builder. And then there's also a watcher that's used as the component that's used if you enable the watcher in the builder as well. There's also icons, so we can masquerade as whatever when we build this client, I should say, or this piece of malware from the builder. So let's actually fire off the builder, and you can see that there are a number of settings. So I can set a victim ID here for my binary. There is this BlackNet URL check. So we do actually have a copy of the PHP hosted on our local system. So if we check the panel, we can see the panel is enabled, which is where it's going to communicate back to for command and control of this bot. There's also a number of settings, such as whether it is going to establish persistence on a system, whether it is going to be using AES encryption or keylogging capabilities, or trying to bypass virtual machines, all of those things that we examined before, whether there is a binary that's going to be bound to this one, whether it's going to be acting as a downloader in order to download a new executable once it runs, and the icon changer as well. So we could go a custom icon, and if we wanted to, we could make this look like Google Chrome. So let's just use that for this point in time. We have it communicating back to our host, and we're going to keep all the settings the same. And if we compile the client, then we get to choose where our output. So let's just call this Chrome.exe and save it. And now we see our client has been compiled. There is masquerading as Chrome. If we highlight over it, we can see the same stuff we saw before in our payload, where it's masquerading as the Windows Update Assistant, yet has the original binary name of SVCHOST.exe. And if we begin to look at the panel that it communicates with, we do have this login panel that's been set up. So on our local system, we'll log in as our account. This is what the attackers would see when they have control over their botnet. As clients begin to check in, it would give them system information, how many have checked in per day, as well as information on all of these things, such as the country they're in, the operating system, the installed date. It will also give them map visualization using the MaxMind database, which has been bundled with it. And then the command center here allows them to send commands to all of the systems in this botnet at the click of a button. So whether that be uploading files, whether that be seeding to do with torrents, whether it is stealing information such as Bitcoin wallets, passwords, whether it's doing a DDoS attack, whether it is keylogging on the system, whether it is sending out spam emails or otherwise taking screenshots, lots of different functions that have been bundled into this particular piece of malware. So that's it. That's all I wanted to demonstrate today, to show you a bit more about the BlackNet malware, the capabilities that it has, how it would look like to an attacker. So K7 Security Labs have created this YARA rule back in 2020 that should still detect this particular payload, this particular malware family, based on some of the hard-coded names and functions that we saw before. But that's it. That's all I wanted to showcase to you today. So let me know your thoughts, comments, feelings in the comment section below. If you're willing, give me a like and a subscribe. Thanks so much. I will catch you next time.